Now in this segment we come to how we differentiate a composition of functions. So suppose, and this rule is called the chain rule. So supposing we have a function which is differentiable at x, and then there's another function, g, which is differentiable at f of x, and we ask what is the derivative of y, which is composition of g with f. So the rule is that g composed with f, the derivative of g composed with f at x is the derivative of g evaluated at f of x times the derivative of f evaluated at x. So you take the derivative of the outer function first, and then you multiply by the derivative of the inner function. So in other notation, if we let y equal f of x, then then the derivative with respect to x of g of f of x is equal to dg by dy times dy by dx. Okay, so here's an example. Y of x is equal to 1 over 1 minus x to the 10. So the outer function is something is being raised to the power 10. Don't worry about what's inside the brackets yet. Take the derivative of that. Something to the 10 with respect to something is 10 times something to the 9. So we get 10 times something to the 9, and then we take the derivative of the inner function. In this case, the inner function is 1 over 1 minus x. So when we take the derivative of that, we get 1 over 1 minus x squared. So the derivative of the outer function evaluated with respect to its argument times the derivative of the inner function evaluated with respect to its argument. So you get y prime of x equals 10 times 1 over 1 minus x to the 9 times 1 over 1 minus x squared. Okay, what if you have two nested functions? Well, the idea is you start with the outer derivative, take the derivative of that with respect to its argument, then multiply by the one derivative in, so say the middle function evaluated with respect to its argument, and then the inner function is you take the derivative with respect to its argument. Okay, so let's suppose we have functions f of x equals 1 plus x squared. You've got a function g defined by g of y equals y plus y squared plus y cubed. And you've got h of z, which is defined as z squared plus z cubed plus z to the fourth. And let's define w of x as h of g of f of x. Okay, so we want to find, let's say we want to find w, the derivative of w at 0. Well, we're going to need the derivatives of each function with respect to their arguments. So the derivative of f with respect to its argument is 1 plus twice x. The derivative of g with respect to its argument is 1 plus twice y, plus 3y squared. And the derivative of h with respect to its argument z is 2z plus 3z squared plus 4z cubed. The chain rule then is dw by dx is dh by dz times dg by dy times df by dx. So we're going to need to know what y is. Well, y is the input to g, which is f of x. So y will equal f of x. And z will be the input to h. So z is equal to g of y, and with y being equal to f of x. Okay. So that's what this means. So we will need to know these values x, y, and z. And we will need to know the values of the derivatives. Okay. When x is equal to 0, then what is y and what is z? Okay, so when x equals 0, well, x equals 0, y is the input to g, so that's equal to f at x equals 0, and that's equal to 1 plus 0 squared equals 1. What's z? That's the input to h, so that's g evaluated at y is equal to 1, which is 1 plus 1 squared plus 1 cubed, which is 3. And w is h when z is equal to 3. That's 3 squared plus 3 cubed plus 3 to the fourth equals 117. Okay. Then what are the derivatives when x is equal to 0? Well, the derivative of f when x equals 0 is 1 plus 2 times 0 equals 1. The derivative of g, see, g has to be evaluated according to its argument. And its argument was y. When x was equal to 0, then y was equal to 1. So we have to take the derivative of g when y is equal to 1. So that's 1 plus 2 times 1 plus 3 times 1 squared is equal to 6. And then h, we have to take the derivative with respect to h. Well, when x was 0, then y was 1. When y was 1, that made z equal to 3. So we have to take the derivative of h when z is equal to 3. So we get 2 times 3 plus 3 times 3 squared plus 4 times 3 cubed is equal to 141. Now we have the derivative of f times the derivative of g times the derivative of h, evaluated with respect to their arguments. So then the chain rule says that the derivative of w at 0 is the derivative of f at 0 times the derivative of g at 1 times the derivative of h at 3, which is 1 times 6 times 141, which is equal to 846. Another example. Find the derivative of f of x, which is this function here. So you have nested functions. So you've got something to the fifth. So take its derivative first. So 5 times the something to the fourth times, now the inner function, what was being raised to the fifth power? The inner function was 1 plus something to the fourth. The 1 doesn't matter when you take the derivative, right? That'll be 0. So it's something to the fourth. So 4 times the something raised to the third power. So you've taken care of that function. Now go to the inner function. The inner function is 2 minus something cubed. The 2 doesn't matter. Its derivative is going to be 0. So you just need the derivative of minus something cubed, which is minus 3 times the something squared. Now the inner function is 1 plus 4x, and the derivative of 1 plus 4x is 4. Now you've gone through all of the functions, and so this is where this stops. Okay, so that was the discussion of the chain rule.